In another video I have made a casting model or pattern on my lathe. Now it's time for showing the casting process. This is done by the company Neer und Saurer, a foundry in Göppingen. It's a really beautiful and industrious place, and I'm glad that I got the permission to film here. First part of the process is the preparation of the mold. The bottom half of the molding box or flask is set onto the floor, where one part of the pattern is laying. The oddly shaped block in the corner will form a cavity to hold a special filter to keep the slag out. The other blocks are sprue patterns. They form the channels which will lead the molten iron to the mold cavity. And here comes a big sand dispenser. The sand is poured into the flask and pushed by hand into the corners. The flask is filled to the rim, and after some compacting, the top is trimmed flush with the rim. After 10 to 15 minutes, the resin that is mixed with the sand has hardened, so the mold can be turned upside down. It's now in the same position as it will be later for pouring. After cleaning away the dust, the top molding box, the cope, is set upon the bottom one, the drag. Then the other half of the pattern is put in place. Also the other parts of the sprue pattern and an internal feeder. The graphite powder is used to make it easier to separate the patterns from the mold later. On the left, an iron pipe is visible. That's the pattern for the vertical parts of the sprue. The internal feeder is covered with sand completely. It's just a cavity with an opening towards the pattern. The iron will fill this space and provide additional liquid iron when the iron in the wheel is cooling down and shrinking. Now the halves of the mold are parted to remove the pattern. The two protruding knobs that are visible on the top part are there to interlock the two parts in the right position. So that's the moment when my threaded inserts in the model become important. 3 hooks are screwed into them, and with carefully knocking upwards, the pattern will eventually come loose. Of course, the pattern has to have no undercuts, and the vertical surfaces need to be slightly tapered. When they finally put the model of the wheel aside after 6 times of molding, it looked quite okay at first, but a closer look revealed some damage. If I had wanted more wheels, I should have used better wood. The next step is the preparation of the mold for the casting. This reddish liquid is a suspension of chamotte. It will form a thin layer on the mold as a protection against the heat of the liquid steel. Because it's alcohol-based, it can be set on fire so it dries and hardens at the same time. Now the filter is inserted and some fireproof putty is laid around the cavities in the mold. Then the top is set upon the bottom and the 2 parts are pressed together with clamps. The second part is the casting process itself. Here's the liquid iron in an induction furnace. Slag is removed from time to time. But the furnace isn't full yet, so another container of scrap metal goes into it. The maximum load is 3.5 tons. When the temperature is above 1350 degrees Celsius, the iron is filled into a casting ladle and brought to the molds. The final measurement of the temperature. Then about 80 kilograms of cast iron are poured into the mold. While cooling down, the iron and the other components, mostly carbon, will form microscopic crystals, and their shape influences the material properties. This will be ordinary cast iron with lamellar graphite, also known as grey iron. Some days later I came back and looked for the wheels in this part of the factory where the fettling and finishing is done. Oh, here they are. 45 kg each and already sandblasted. Next we will have to drill the holes into them, then they will be ready for use in our cannon project.